Okay, for this last component, we're going to look at the ecological footprint in terms of how much coal anthracite would need to be mined in order to make the iron required for your first car. Anthracite is a really high carbon content type of coal, 92 to 98%. It's not used anymore for electrical production, but it is used in many industrial processes because there is so much carbon in it and so few other impurities, which makes it good for smelting reactions. Now, we've already established in the first two video lessons that we have 820 kilograms of steel, iron for the steel approximately used to make your car. That gives us 820,000 grams. We've used our formula for calculating moles by taking the mass, dividing by the molar mass. In the case of iron, the molar mass of iron is 55.85 grams per mole. So if I have 820,000 grams, then that's 14,682.18 moles of iron. Using this information, I can now start to determine how much carbon would be required for this reaction. So I need to look at my mole ratio between carbon and iron. And that's the beauty of doing stoichiometry, is that this becomes very easy. I see that there's 3 moles of carbon are needed to produce the 4 moles of iron. So using this, I can quickly use my ratios to establish how many moles of carbon that's going to end up being. So my moles of carbon is 3 moles to 4 of iron. Of course, my unknown here is the number of moles of carbon, so I give it an X. And I do know that there's 14,682.18 moles of iron. So I will rearrange my formula, cross my 14,000 up to the 3, so it would be 3 times 14,682.18. Divide all that by 4, and I'll get an answer that looks like 11,011.64 moles. So I now know the number of moles of carbon. I'm going to write that right here. Now, my molar mass, pretty straightforward. I just take the molar mass of one carbon atom, or the atomic mass, if that makes a little bit more sense, because we're only dealing with one. So the atomic mass of carbon, or the molar mass of carbon, is 12.01 grams per mole. You could round it to 12, no big deal. And so now I've got this information, I need to calculate my mass. Again, over here we established that if my moles is my mass over my molar mass, then to find mass by itself, I would just cross the molar mass up, multiply by my number of moles. So I have 11,011.64 moles times 12.01 grams per mole. My moles there cancel out. Notice that my masses are always in line. Molar mass is always in line. Number of moles always in line. It's really helpful if you set up your equation like this, or your work like this, because then everything is nicely organized, and if you make mistakes you can easily figure out where you went wrong. So I get, in terms of my mass, 132,249.7 grams. And that's going to give me 132.2 kilograms. Alright, so again, able to figure out the mass of carbon that would be needed in the coal. Now, if we know that the amount of coal to amount of carbon is 1 over we'll pick a number between 92% and 98%, so we'll say 96%, so that'd be 0.96. So if I have a ratio there, I can easily figure out the mass of coal coming that would be required. So my coal, that's my ratio of coal to carbon. I know that I don't know how much coal, my overall mass of coal, but I do know that my mass of carbon is 132.2 kilograms. Now I want you to use this information and the density values for coal in order to figure out what the actual volume of anthracite that would be required to be pulled from the ground. The density of coal rests between 800 of anthracite coal between 800 and 929 kilograms. In this case, we're going to work with kilograms per cubic meter, so we'll get a chance to do less conversions. So what we'll do is we'll say that the density for our purposes of this coal is 860 kilograms per cubic meter. So once you figure out the number of kilograms of coal that would be required to be removed from the ground, I want you to figure out the volume of coal, knowing that the density of the coal that we're hypothetically choosing to mine is 860 kilograms per cubic meter. So that's your extension for this video lesson, and of course the answers will be posted, the solutions will be posted up on the web page. Good luck.